Welcome back, dear students. In this lesson, let's discuss about scope in Solang Solidity and compare as well with vanilla Solidity for EVM compared to Solang Solidity, any differences or similarity with them. Now, when you talk about scope, basically scope is, I've given you an example already when we talk about state variable. So it's a scope because within this contract, for example, this contract block code, you can see it and here, between it, whatever is inside there is a scope of its own, which is what I call those state variable. So anything you put in there, it's a scope of its own. Now, each of these, like this enum, whatever is here, is like it has its own local scope. That's why you cannot just access anything in here anyhow, except depending on how it has been declared. So that's what scope it's all about. And then I've explained you have like state variables when you declare that it give you access. Anything, functions, whatever can call this at any point in time. They can easily call them at any point in time. But if it is inside a function, like I've told you, this local variable, for example, then except like maybe this is return and call, another one cannot come here now. For example, I can say this is SPL token, right? So I can decide to take this and say I want to set it here. You can see because this was returned. You understand? So except this has been returned, you should understand that supported variable declared within a block or function and not accessible outside the block where it was declared. So if we declare it like this, it's not accessible for me just like that, except this now as return it, I can tap into it and try to reuse. But usually this is declared, I cannot just take it and decide to use it right here, it won't work. But if it is declared within the state variable scope, which is available to any code, as many functions as possible, you have 10, 50 functions, they can always undo this state declared variable. So that's why if you know you want to be accessing that value from different function, you had better declare it as a state variable. Then you can manipulate it with any function as much as you like. We have learned about how to declare our variables, and it's supported using similar names of an existing variable, though I don't recommend it because it can create a shadow. Like most times you will even get error if you try to declare the same name. For example, if I try to uncomment this out, you see number already defined as a contract variable, so you can see it now. So it instantly shouts at me that there is an error there. So then we have if statement. I know I was telling you all these operators you can use to compare that is this number greater than this. So if this n is greater than 10, then do what is inside this code. That's what we've got here. Let me just so you can see it very well in the code. Let's place this in a function. So you can see it that if n is this, then do something. That means if this is evaluated to be true, then run the code inside this block. So, but if it is not, then you don't run it. Then you also have S, that you can use S with it. That means whenever this doesn't evaluate to true, what else should the code do? Then it should go and run whatever you have inside here. You understand? So it should go and run whatever you have inside of here for you. So similar to that, you have while statement. Now for the while loop, instead of the if that just check once is 2 greater than 1, if yes, then run that code. If not, run the code inside the S, as simple as that. But what about if you want the code to keep running? Keep running, that's when you use while, because once this executes, it stops. It doesn't go back to this if again and then run, no. If you want a situation like that, you want to run maybe a kind of a counter, like, okay, as long as this thing is occurring less than 10 times, then keep running the code. So in such a case, you don't want to use just if, you use the while statement, conditional statement. So in that, not greater, so let's say 11, yeah, if I'm to follow what we have here, 11, 12 and things like that, it will keep running. Then if it's not, it doesn't even run. That is paying for the transaction, it will just consume. So you don't want that. In such a case, then you can use a kind of break. You say supported can use break or continue. You understand what I'm saying? So if you don't break it, it will be an infinite loop, and you know what that means. It will keep consuming. You are dealing with smart contracts, not just pure JavaScript that will just exhaust just your maybe system memory or users memory. No, this will be using gas, which is you are paying Solana or so to pay for the fee, and then to keep using it on till your account is dry. So you don't want that to happen. Then you have the do while statement. So do this while this is valid. You understand? So supported block executed at least once. Then same for what you have on the EVM vanilla Solidity. Then for statements, is it for this has a lot. Let me try and put it here for you. You can see it that for this equal to this, then execute this code and keep adding this. You remember this arithmetic plus 100 as long as this is valid. Remember, as we are checking this, so as long as this is valid, add or subtract or whatever you are doing this, and then continue with this I. You see I is less than or equal to 1000, then I plus 100. So for example, if this code is running and I is 800 already, then it will still add 100 to it. It will make 900, and it will come back again. It will run this code. Then this becomes 900. Then once it runs this, it will stop, because this will be 100 plus 1 makes 1000. So that's when it's less or equal to 1000, then this code will stop. So these are things, like I said, you don't need to bother to try to keep them off head if you are just beginning. But if you're already coding with Solidity, vanilla Solidity, all this basic, you already understood them. So they are just there to have idea, because you'll be seeing them. Then having idea, it's good. It's not about keeping it and just knowing everything. No. Now you can have the structuring destructuring statement. Supported can ignore return value, then the same as well. Then you have the try and cache statement. So this usually when you run a smart contract, we call it atomic transaction. What that means is that if you have this code, for example, and things are running, everything needs to run, and only this line as issue is not running, every other code that have been run here will be reverted as if they never happened at all. So it's like it's either all this code run successfully or none run at all. So even if it has run to 99% and just 1% of the code fail, then the whole 99 will be rolled back that it never happened at all before. So, and in such a case at times, even while that is trying to roll back, you still want it to catch some error and continue. So that's when you use try and cache, but that is not supported currently in Solang Solidity as at the time I recorded for this lesson. So maybe in future, because on Solana, once that 1% fails, everything gets rolled back. So there's no like trying to cache and then try to patch things up like you have it on EVM. So that is how the statement works. We've learned the scoping, the conditional comparison statement and things like that as well. And this as well give you an idea how to use some of those operators we have discussed before, equal to, greater than, and things like that, like we have used them here. So you can always check the resources to learn more and read more about this. You can see any transaction that fail halt the execution of contract entirely. So try cache statement is not supported for Solana programs. So that is it for this lesson. I will see you in the next one. Keep the program spirit and alive. I remain Solomon Foske. Peace.